Now let us move down to question 4. Solution to question 4. Now if you look at question 4, you pause and you read the question and then you write it. Please do that. Alright, so after having all of this, let's proceed. So A is a solution containing 2.52 grams of H2SO4 in 250 cm cube. So A is standard because from here we can get the concentration of A either in gram per dm cube or in mole per dm cube because we know what A is, H2SO4. B is a solution that is obtained by dissolving 20.0 cm cube of a saturated solution. Now we are not given the volume that was dissolved. We are given the volume that was dissolved, but we are not given the concentration of what is being dissolved. So that means in this case we don't know our initial concentration. What we are using for B now is our final concentration because they took a saturated solution. They took 20 cm cube and dissolved it in 1 dm cube. That's the meaning of per dm cube. So whatever we get now will be for the conc of B mole per dm cube will be C2. The conc of our saturated solution will be C1. Now let's proceed to the question. Obviously, our mole ratio from acid to base is 1:2 also. Now, the conc of A mole per dm cube, how do we get that? So we can get that by simply using the formula. Go to the next slide. Formula is mass over molar mass times 1000 divided by V. Again, we show how we get the molar mass. What's the molar mass of A, which is H2SO4? Molar mass of A is 2 times 1 plus 32 plus 4 times 16. That will give me 98 grams per mole. So if I'm to find the conc of A now in mole per dm cube, it will be 2.52 divided by 98 multiplied by 1000 divided by 250. 250 because that is the volume of A that was being prepared, 250 cm cube. So after everything, the conc of A will give me 0.103 mole per dm cube. Now, the conc of B, like I said, the conc of B will be my C2 in dilution factor because I took 20 cm cube of a saturated solution on its own and dissolved it in 1000 cm cube of solution. So that means my initial conc of my saturated solution was not given. Whatever I get as B will be my final concentration of the solution. That is C2. But let's proceed. So we don't know how to get C2 in any way because it's not standard in any form. That's why we are simply using CAVA over CBVB is equals to NA over NB. It's very important to write your mole ratio over C to base. It is 1 mark, always 1 mark. NA is equals to 1, NB is equals to 2. Now, in this case, I'm using V as 12.20, isn't it? Because that's the titer value that I've derived after multiple titrations. So VB is volume of the base that is pipetted. So that is 25.00 centimeter cube. So from there, I will make CB the subject of my formula. CAVA NB over VB NA. After substituting, I will get CB as 0.101 mole per dm cube. Now, how do I find the solubility of NaOH? The solubility of NaOH is the concentration of my initial saturated solution. That's when I will now use the dilution factor. C1V1 equal to C2V2. So C1 is what I'll be looking for, like I've stated earlier. C1 is what I'll be looking for. So if I mix one is of the formula, I will get C2V2 over V1. So after this substitution, it will be 0.101 multiplied by 1000 divided by the volume of my saturated solution that was used, which is 20. So doing all of it, my initial concentration would appear to be 5.05 mole per dm cube. Now, in the last part of the question, which is go to the next page. The last part of the question, which is mass of NaOH in 1 dm cube of saturated solution. What I can do here is that mass of NaOH in 1 dm cube simply means one thing. It simply means mass concentration. Because if I have, like, let's say I have 2.0 gram per dm cube, that means I have 2 grams dissolved in 1 dm cube. So they say, what is the mass in 1 dm cube? That means they're asking me what is the mass concentration. Now I know that mass concentration is equal to molar concentration multiplied by molar mass. So what's my molar concentration? That's 5.05. So my mass conc will be 5.05 multiplied by the molar mass. You must show how you get your molar mass. It's very important with the correct unit. So 23 plus 16 plus 1, which is equal to 40 gram per mole. So in the end, our mass conc will be 5.05 multiplied by 40. That will give me 202 gram per dm cube. So this statement simply means I have 202 grams of NaOH that would remain in 1 dm cube of the saturated solution. That's it for question 4.